All right, welcome all of you for this next session in our series of Getting to Know Visum. This session is on model calculations implemented through scripting. For the agenda for this session, we're going to cover an overview of how scripting works with Visum, give an overview of the Visum object model so you get the general flow of data. Also discuss script interface specifically with Python, since Python is the more supported scripting language that we have with Visum. We'll discuss a helper library that we have created to make your life easier with interfacing with Visum with some preset canned methods called Visumpy. So we'll have an overview of what you can do with Visumpy and how to use it. We'll also discuss some other Python libraries that are typically useful, and these are useful in implementing model calculations or calculation of matrices in large arrays and some other functionalities such as Monte Carlo simulation and such. These would be NumPy and SciPy. And then the GDAL library for GIS functionality if you're looking to automate a bunch of GIS operations using Visum and Python. We'll go over some script examples that we've created so you have an idea of how to structure and lay out scripts in Visum with a Visual Studio editor, or you can also use any editor of your choice. So let's get started with the overview. So Visum scripting engine supports COM, which means that any COM compliant language can be used with Visum in general. For example, you can interface with Visum using Python, VBS, JavaScript, etc. So there isn't really a restriction on what type of language you use with Visum as long as it's a COM compliant language. Now, scripts can be run within a procedure sequence, or they can be run on the fly, and that depends on what type of work you're doing with the script. If it's just some one-time calculation update or functionality that you're using, then you can simply use the on-the-fly script call. But if you're embedding a script inside a model calculation, then you would typically run it within a procedure sequence. We recommend using Python scripting with Visum because it is one of the more appropriate scripting languages that can be used for modeling and doing the sort of calculations typically involved in travel demand modeling. These might include calculating more complex utility functions, performing transforms on matrices, doing lookup calculations for link capacities, and so forth. So Python scripting has the support for vectorized array calculations and such, which are very useful for implementing such functions and operations. Typical script operations in Visum can be classified into the following. So one type of operation that you would typically do with Visum objects is getting and setting data. This would be getting data from links, zones, matrices, and so forth, performing some type of calculation on that data, and then setting it back. One of the classic example would be link capacity calculation updates. On the zone level, it might be computing accessibility for a zone or a trip generation calculation on a zone. And then for matrices, it would be some sort of utility transformations that you might be feeding into either a gravity model or a mode choice model and such. Then you can also use scripting and automation in Visum to call procedure calculations. Now, let's say you have multiple sets of XML procedure files stored for different times of day, let's say. You can batch run these XML file procedure calculations by loading these and executing these in a batch format with scripting in Visum. So this way, even if you're doing some scenario calculations, you can automate or batch run those scenario calculations with Visum scripting. Then scripting also allows you to automate functionality within Visum, which might be linked to special features like isochrone calculations or certain select link calculations or batching data in and out of a net file or a transfer file. So these would be features linked to some of the operations that we've seen earlier, but then this scripting interface allows you to automate the calculations if you're doing them repetitively over multiple either parameters, network objects, or different scenarios of files. As I said before, in general, any COM compliant language can be used with Visum for scripting. However, our focus on these sessions will be on scripting with Python because this is the most supported language that we have, and also there are resources available widely, even some training available that FDOT has posted related to Python. So this kind of overall blends into the workflow and structure of how a lot of the modeling work is being done statewide as well. So one key thing to understand Visum scripting is to have an idea of how the Visum object model is structured. So if you look at Visum, it's an object-oriented structure, and the Visum object is kind of the overarching object or the master object, which contains further objects, which would be network objects, matrices, and so forth. And then this Visum object actually is persistent in the memory once you start Visum, and this can be accessed by scripts run from inside of Visum, which means that if you're running a script from within Visum, there is no need to explicitly invoke or dispatch a call for the Visum object as such. You can simply access that as visum.net.links and such. But if you want, you can also automate Visum by calling it externally. And this way, you would use a COM dispatch in Python and create that Visum object explicitly and then operate on that Visum object container accordingly. Now, each object within the Visum container has some attributes. It may have some methods associated with it and related objects also associated with it. For example, you can see over here how the links object is structured. So the link object is connected with turns that come in and out of it. It may have then time varying values. And then it has a bunch of methods. So the links container, you can see, has methods such as adding or removing time varying attributes or a user defined attribute. You can get a polygon or generalize a polygon. You can also get multiple attributes at the same time. So let's say you're doing some sort of a capacity lookup calculation, which depends on area type and functional type. You can retrieve an array of multiple columns like that, operate on it, and send back the results. So that's what the multiple attribute would be typically used for. And then several other methods, as you can see over here. And each of the Visum objects will have a similar structure in that there would be a zones object, which will contain also the zone, and then a set of methods and attributes associated with it. When we say attributes, it's usually one of the fields in the columns that you see, and those fields would be let's say on the link level, capacity, speed, allowable transport systems on the link and such. For the zones, it would be some values related to dwelling units, accessibility, and then also things like population, employment, and such. So the way to get into these objects in Visum is you go from visum.net and then the object name, and then the hierarchical flow goes from there. We'll of course have a look at how this works within the Visum interface after we discuss the overview. So the script interface with Python in Visum works like this. We've provided a scripting console via PyCrust, and you can invoke this console and use Visum interactively with the script interface. If you're trying to test out some functionality, you're trying to test a little piece of code that you'd like to use in a larger implementation, or you're just trying to debug certain errors and such that you'd like to type interactively and see the outputs piece by piece or chunk by chunk. So this PyCrust functionality connects you to a Python console which interfaces with Visum. You can see over here that we have visum.net.links and then get multi at values gets an array of values or a column of link attributes specified by the user. Then scripts may also be run using an interactive script menu or by drag and drop operation. So if it's just a one-time operation that you're doing with a script, you can simply write up your script and drag and drop it over Visum, and that'll run the script. More typically, scripts within Visum model calculations are embedded in a run script procedure, as you see here. And then you run the script within that entire procedure sequence to perform a certain calculation. You can specify the script in two ways. One, you can link the run script procedure with an external Py file that you've written. The other way is to specify the script code directly in that run script menu, where over here you can see that you can pick the script environment. Here we have Python 3.7 and then some code entered for doing a certain operation with a script. Now regarding the script environment in Python, at the moment we are allowing two script environments for Python in Visum. You can use either Python 2.7 or Python 3.7. Going further, we will be removing support for 2.7 and allow you then to fully migrate to 3.7. So if you're starting to script something in Visum now, we recommend that you use Python 3.7, and that way your script will not need further updates when the 2.7 Python is not supported anymore within the framework of Visum. Now, to make life easier to work with Visum in Python, we have developed a Visumpy library that allows for different types of functionality, and different types of features are implemented in this library. When you install Visum, the Python interpreter and some of the Python distributions are bundled in that install. So if you're installing Visum, it's recommended that you go through the entire installation and not skip the Python installation, so you'll have all of the required libraries within your Visum installation. The benefit of this is also that you don't have to then, as a post-process, install some new Python framework or Conda or any of these things. Once you install Visum, everything gets installed in one go, and you have the libraries that you need. And if you need then more libraries, you can use the pip install interface to add other libraries that you might use with Visum. So Visumpy, as I said, contains features and functions that make it easier for you to work with Visum and Python. It has some of these submodules that are typically used. So Visumpy helpers has special get and set methods for network objects and matrices. The more important one out of this is for the matrix, which allows you to get a C-style pointer matrix, which saves a lot of memory when you're working with large-scale models. For example, in the statewide model, you have about 10,000 zones. And for that scale, it's really useful to have some of those matrix get and set methods. Then we have a specific module for Visumpy matrices. These are wrappers around typical matrix operations that you might perform, such as getting row and column totals, then read or write binary matrices in and out of Visum, and such. We also have a Visumpy TK module, which you can use as a module to pop message boxes and those type of widgets that you might have for file selection and so forth, implemented in a quick framework. Then we also have a TI support module, which you might end up using if you're using a lot of time varying attributes in Visum. This is the typical case when you are using, let's say, simulation-based assignment or other dynamic methods within Visum. And this helps you get and set time varying attributes more conveniently. Some of the other libraries that we also package in the Visum distribution or installation include the NumPy library. This is a library that's very useful for numerical operations and vectorized array calculations. So this is built over a framework that is optimized for handling large arrays and makes it really fast to compute utility transformations or other such matrix calculations that you might be doing for finding, let's say, friction factor lookups and such. Then the SciPy module is again useful for numerical operations, but it also then has support for sparse arrays, which means that if you're working with certain matrices that are huge but are sparse, then you can make use of this sparse array support within SciPy to do really fast dot products and such for the matrices. It also supports other statistical and graph computational functionality. For example, it has various shortest path algorithms and such if you're working with some other sort of alternative data or you want to experiment with different accessibility calculations at a more disaggregate level for which a certain network object is not available in Visum, then you can use some of these methods within SciPy. Another important library that we also package with our distribution of Visum is the Osteo flavor of GDAL. And this geospatial data abstraction library is very useful for bulk automated GIS functions. This might include buffering, point in polygon type of operations, intersects and spatial joins, and then it also provides functionality for translating geometries into different formats of files. For example, if you want to pull some data out of Visum and export it to a KML file or WKT or GeoJSON, interface with geodatabases in a customized way, or read some shape files as custom operations. All of this functionality can be accessed by using the Osteo's GDAL module. Now, let's have a look at some of what we discussed with Visum and the scripting interface, and this will give you a good idea of how the overall framework is structured. So I go to Visum. Over here, you can see we have the scripts menu. Here, you can either run a script. So if you click this, you can select a certain script that you want to run and click open, runs the script. Then we also have this Python console, and this is the PyCrust console that I talked about earlier. So if I select that one, it brings up this console. Here you can interactively type and get objects within Visum. Now let's see how to use this with some of the libraries that we discussed. So let's say I want to use the Visumpy library. First I import that. So I go for import py.helpers and I'll just import that as H. So that imports the Visumpy helpers library. Now let's say I want to get a certain attribute out of the links. Then I can go for, let's say, link speed is equal to h dot. We have the option to get multi. And since we want links out here and an attribute from the links, we have to specify that container over here. So in our case, the container is visum.net.links. And then we have an attribute name. So link speeds in Visum are stored in an attribute named v0prt. So let's have a quick look over here. So you can see over here this v0prt is the speed attribute, and the code for this is v0prt. So I'll type that in over here as a string. And then this is a default argument, so I can skip this. And then when you hit enter, it'll put all of the link speeds from the links in this array. So if you look at the number of links over here, we have 5008 links. And then if you get the length of this array, that's equal to the number of links. Another way to count the number of links in this case would be directly to use the count method that's provided in links. So you would go visum.net.links.count, and that also prints the number of links in this network. If you want to access elements of the array, those are done by a zero-based indexing. So let's say I want link speed for the first element. I'd say link speed of 0, and that's then 46 miles per hour. And in the same way, you can iterate over different attribute values in Visum. Now this way we got one particular attribute into an array. If you want to get multiple attributes or columns at the same time, let's say now we wanted 3 items. We wanted the link length, speed, and capacity. Then we can retrieve those all at once. The way to do this would be again to specify target array. Let me call that link data is equal to visum.net.links.get multiple attributes. And here we specify these attribute IDs in again a list. So we specify a Python list of these attribute IDs. In our case, we want, let's say, the length. So I'll specify length and then capacity and then let's say the speed. This way I can get multiple attributes at the same time into that linked data array. So now if I hit enter, it pulls up all of the linked data in that array. And then now if I look at the first one, it'll give me 3 columns here. So it gives me the length, capacity, and speed for that particular link. You can iterate over these in the same way by using for loops. So let's say I want to iterate over this link array. I can go for length, capacity, and speed in link data. Print. You can again go for link capacity and speed. And this way it'll print the entire array. So over here, I'm not going to proceed with this statement because it might print all of the, or it will print all of the 5008. So I don't want to flood the screen. So in this case, this illustrates the syntax for it. Now, one of the things with vectorized operations supported with Python is that you need not iterate over every link object to calculate multiple rows of data. So here, let's say I wanted to do an operation over the link speed and half the link speed. You can simply say link speed. If you want to store this in a reduced speed different array, equals link speed multiplied by 2 or 0.5. So over here, our data is stored in not in an array or a NumPy array. So that's why it didn't allow the entire value to be multiplied. So what we do in this case is then cast this into a NumPy array. So here, the default data structure returned is a list in Python. If you want to convert this into a NumPy array, we simply go for import NumPy as NP. And then you can cast this data into an array. So you can say link speed equals p dot array, and then that converts it into a NumPy array. Now let's see what happens if we try to scale it again, and then this time it goes through. So now if I look at link speed first element and link reduced first element, you can see that that's 46 and 23. So the entire column was multiplied by 0.5. So this is an example of kind of the vectorized operations that NumPy supports. And the typical workflow in this case is to obtain the object into an array from Visum, perform certain functionality on it, and then send it back. So here, if you wanted to now send back these reduced speeds into Visum, you can use again the set multi. So you could go for h dot set multi. Again, I specify the container over here as links. So visum.net.links. The attribute I want to update over here is the speed. So v0 prt. The values that I just updated are in the array link speed reduced. So I can then simply copy and paste that over here. And I want to do it for all. So this would be a statement for sending the updated values back. So now over here, you can see that the speed is 46. Now, once I do this, that should become 23. So now the array was sent back, and now you can see that the speed is 23. So for all of the links, we have halved the speed. If you want to set back the original values again, then you can just set back that array, and then that changes it back to 46. So this is one way of getting and setting link related data. This works the same way for zones and any of the other network objects. Then you also have the matrices. If you want to get a matrix, then the workflow with that would be, let's say we want to import a matrix of this external trips, EE trips. What we'll do in that case is we'll say EE trips as the name of that array, and then h dot. There are various functions over here now you can see for get matrix raw. If you have large arrays that you're operating on, we recommend using this get matrix raw because this gives you a C-style pointer, which is much more efficient to read and write into Visum. Now, for getting a matrix, you can use either directly the matrix number. For example, over here, the matrix number is 1, or you can get that through some sort of a definition of code. So let's say you had a string related code on your matrix, it'll return that matrix. Or you can give a dictionary specification for returning that matrix. So here again, we know that the matrix number is 1. So we'll say get matrix raw from Visum 1. And we don't have a matrix to put it into because over here we are already specifying that explicitly. So once you have this, you can click enter, and that loads that EE trips matrix into an array. Now let's say I want to see what's in this. Let's take a look at the sum of this. So if you do eetrips.sum, this is a NumPy functionality, you can get the total for that matrix, which is 63,820. And then you can see over here that that sum total is also 63,820. You can also do summation in one axis or the other. So this way, if you want, let's say, axis sum, then you can go for EE trips dot sum along axis, and then this gives you sum along the axis. So let's say you have over here, first element is 0 because this is a external matrix, so it will be sparse in that sense. So over here you have, let's take a look, most of these values as 0, and then all the way down here towards 635 you have certain row sums. So then you can go for a sum. Oh, this is a 592 matrix over here. So when you put an index of 634, it goes out. So here you can see that the numpy matrix is one indexed and it doesn't relate directly to this index. So in this case, if you want to then create a functionality where you want to look up those indices, what you can do is get the zone numbers and use a dictionary to look up the index of that zone number. So let's try that, and then let's try this again so that you have an idea of how this indexing works. So for the zone numbers, we have, I can say z nums equals h dot get multi, and then I want visum dot net dot zones, and I want the zone number over here. So that pulls zone numbers in a array. So if I look at znums 0, that goes from 1 to the last one over here. Oops. 653 would be the last number of the zone over here. So you can see that the zone number corresponds to these numbers. Now we want to link this with the index. So we know the number of zones in this is 592, which you can also count by using visum.net.zones.count. And then we have the zone numbers retrieved in this znums array. What we want to do is create a lookup using a Python dictionary. So what you can do in that case is create an index array. So to create an index array, you can say zix equals range 592. So this will be an index array, which we will link with the zone numbers. So to do that, we can say z lookup equals dict, which creates a dictionary. And then you can say zip together znums over here with z index. This will create a lookup function. So this way you can have z lookup, and then if you look at 634 now, that will give you the index 572. So now if I look up a sum using this z lookup 634, or let's say here 635, that gives me the 1686, which is also the sum over here. Oops. Looks like it's killed my connection with the license somehow. All right, so this way you can get and set matrix data as well as then perform operations on the matrix in a vectorized format. Now I've created some script examples that you can have a look at. And one of the things that you will need for writing your Visum Python scripts is a decent interpreter. By default in Visum, we supply you with the interpreter for idle, which over here, let's have a look, is a fairly basic and minimal type of interpreter in Python. So this basic interpreter with a console will be installed when you also install Visum. And here you can load your scripts. For example, let's say I want to use this script. You can load this script, write your script, and it maintains your indentation and so forth. But this is a fairly minimal kind of a interpreter, and it doesn't have the more detailed linting. You can't necessarily see notebooks, or if you like working with Jupyter notebooks and such, you can't see any of those in here. So for those, I recommend using the Visual Studio IDE, which is now a pretty nice one. So it's called VS Code. And this also supports the linting and such for Python scripts. In here, you can also have all of these scripts, for example, stored in a Go. So that way, if you're looking at these different scripts, you can scroll through these scripts and then use these scripts for different functionality. So I've supplied with this particular example file different scripts that you can use to get familiar with interfacing with Visum. One of these over here is with the geometry buffering with OGR, in which what you can do is import in the same way Osteo OGR library, and this links to the GDAL. You can create a point by creating an OGR geometry over here. And once you create that point, it has certain methods associated with it that you can use. Here, you can create a mile buffer along that point, and then use that buffer geometry to do functions like contain tests, or if a certain point is within that buffer, you can then perform certain functions with it. This is typically something you might use in your destination choice models and such, or for picking accessibility or counting items. Like let's say you have survey data and you have the XYs from the survey data that you want to intersect with the Visum zones or zone polygons, then you can link all of those using this OGR or GDAL library, which supports all of the functionality for buffering and such. Then another example would be automating select link calculations. So here we define the demand segment. You can specify the from and to node of the links, and then set the network elements, which is how many links you want to do the select link on. Insert that link in the net elements, and then use this special flow bundle calculation object over here, and then call that in the execute net element. So what this does is calculating the select link or flow bundle over the network elements that we just created over here. So this link is used for the select link calculation, and this can be extended to a combination and so forth. So anything that you would typically do with the GUI, you can automate with this COM scripting in Visum. Here we are then automating a path listing, and then finally clearing out the flow bundle. In a similar way, you can also automate isochrone calculations in Visum. This is again provided through this analysis isochrone functionality. You can also automate shortest path searches between nodes. Over here, I'm looking at a series of waypoints, which is basically the node numbers, and then doing a continuous shortest path over the entire sequence of nodes. This might be useful if you're trying to map a tour or looking at some cross-validation of tour lengths and such one by one, or through some survey data. Now with this, let's also have an overview of the calculations that we've implemented for this Olympus learning model. So let me go back over here to the Olympus model in the scripts table. So we have all of these scripts implemented in calculating the flow of the Olympus model. This whole folder can then be looked up over here. So here I can go for File and then Open Folder, and then select that folder. Then all of these scripts will be available for browsing in this folder. So let's take a look at a few of these scripts. So here I'm applying peaking factors to convert the PA matrices to OD tables. So you can see over here that I've written a function and then called this function over here with the different parameters. So the overall workflow, again, you can see is that take a few functions, declare some arrays, run some operations on these arrays, and then finally set these arrays back into Visum. Then we have functionality for friction factor calculation. Over here, we use the NumPy interpolation function. So here I'm getting a skim matrix in, running that skim matrix through the interpolate function in NumPy, and then constructing that friction factor matrix, and then sending it back to Visum after the lookup is completed, and then running it through a gravity model calculation. Over here, I have a function for updating trip attractions. So I look up these, I pull some production data in here, run some balancing calculations, and then set it back to Visum. And you can see a lot of these functions essentially do similar operations where, let's say you have auto ownership, we have a function and a table name over here with the coefficients of the auto ownership model. We build that coefficient matrix, do the utility calculations, and send back all of the auto ownership shares back. In this case, I'm saving that data into a CSV file through NumPy, and that's why you see the save text over here with the extended cross classification for the autos. Similarly, you can calculate the destination utilities using the coefficients. Again, there are marginal calculations that we use in that IPF for the joint classification model. So you can see there are various array and vector calculations that are being carried out with this overall same workflow of get the data from Visum and then perform some calculation and functionality over it, and then send it back to the result attribute or the result matrix. So we will in the end also package and upload all of this model and the files associated with it, and also some of the script examples that we discussed, so that you have a good idea of how this whole process is working and you can explore on your own how some of the functionality works. A lot of it with getting familiar to it with any scripting is repetitively doing it and then trying it out yourself. You might see some errors, but then you can work through those errors with just repetitively going over troubleshooting and such. So uh, mostly scripting with Visum, or in general, like any scripting or programming, is a matter of practice and repetition. So we saw some scripting examples over here. The overview of that is we can get and set matrices, link zone, or network attributes. We can run a procedure calculation, create listings, GDAL functionality, or you can start Visum from outside using the Win32com type modules. And the main tip over here is to use functions in Python, as I showed you over there with the def function and then function call. What that does is it automatically deallocates all of the arrays that you loaded in memory. Otherwise, those arrays might remain persistent in Visum and then just rack up RAM for no good reason. So the best practice over here for using large array calculations in Visum and Visum script or Python scripting is to always define the main function that you're doing with Python as a Python function, and then call that function, so that all of the arrays that you use in that overall calculation remain in that function. They get created during the function, and then once the function is completed, those get automatically deallocated and your memory is cleared.